Alright, this is Nicholas Brooks for FTT 101, Mechanics in Firearms. This is for the Module 2 assignment, discussing simple machines and a little bit of the math and physics behind it. So a couple of things I use in my everyday life. Knives are nothing more than a sharpened wedge. Without those, really hard to cut stuff. Vehicle I drive is a manual transmission. I have to shift every gear independently, and in order to do that, I have to have a lever to be able to do that. The wheels on it go through and make it so that you don't have to have nearly as much power to try to move from one place to another. Object in motion tends to stay in motion. Without the basis of any of the simple machines, you remove one and a lot of them become less useful, because with our modern lives we need more complex machines. Yes, you can still get a lot done with just the basic 6 or the 7 that's included with SDI, including the spring. You remove any one of those, and because technically a pulley is nothing more than a wheel and axle setup. So I mean, you take away the pulley and you kind of get rid of the wheel and axle, you get rid of the axle, or the wheel and axle kind of gets rid of the pulley. And everything is so dependent on each other. Yes, they can all exist within their own right, but a lot of them are used so much in conjunction with the other that it's hard to imagine even having just one of those pulled away. For a lot of things, they are the basis of simplicity, and you're not going to get much more effective and in many cases more durable than the basis of those 6 or 7, in this case, simple machines. Okay, for part 2 of this, they're wanting us to go through and use 2 simple machines and demonstrate how they make work easier. Wheel and axle, it's one of the first ones that always comes to mind for me, because I've done strongman training in the past, and if you have a static object just on the ground and you have to push that with the friction that it's imposing, it is so much harder to move than if you have some type of cart underneath, because yes, you still require that initial force to get it moving, but once it's moving, it stays moving. Unless you're going up, say, an inclined plane, in which case requires more effort. And with pulleys, depending on whether or not how you have them configured, with just one pulley, it's a 1-to-1. You can basically almost design a transmission, for lack of better words, with just a system of pulleys to be able to affect the amount of weight you can lift with force exerted just by adding in, okay, I need more distance. Every time you add another pulley, you're decreasing the weight by half, but you're also increasing the distance you have to travel that weight. So that's going to include this week's video.